And before the throne there was a sea of glass, like unto crystal. And I saw, as it were, a sea of glass mingled with fire.
Since the 3rd millennium BC, materials like these have been used by different civilizations to create a substance that draws on the 4 elements: water, air, earth, and fire. The fascination of crystal has endured, and here, in a modern glassworks, on the edge of the 21st century, the people of Edinburgh Crystal are carrying on traditions whose worth and quality have been established over hundreds of years. Crystals, such as quartz, are forged in nature's own vast furnaces. Over the centuries, they've been admired for their intrinsic beauty and, at times, revered for their healing properties.
Clear quartz is unsurpassed in its beneficial effects on the brain and the soul. Rose quartz releases anger and greatly profits the spleen, kidneys, and circulatory system. It also increases fertility.
Glassmakers have always worked to bring alive the beauties that are locked away in the raw materials. But the story of glass isn't just one of ancient history. These are the furnaces of today, and their magic is very modern.
All crystals are classified into 7 systems: cubic, tetragonal, orthorhombic, hexagonal, trigonal, monoclinic, triclinic. Their properties are defined.
Glass has been with us for well over 4,000 years. There have been many techniques for shaping and using it. The earliest methods involved cutting and grinding raw blocks of glass into shapes, and molten glass was also poured into molds. But the greatest discovery came on the Phoenician coast in 100 BC. It was there and then that glassmakers started blowing into glass to form bubbles. The sort of glass that interests us didn't appear until the year 1676. It was then that 2 English glassmakers created lead crystal by adding lead oxide to the glass mixture. This crystal glass was heavier and less brittle than other glass, making it easier to cut and decorate. With this discovery came the development of the art of glass cutting. It's a craft in which the designers and cutters of Edinburgh Crystal excel. The company's origins stretch back almost 4 centuries to the 1600s, when the Venetians brought the techniques and skills of glass blowing to the Edinburgh area. Over the years since then, demand for glass in its various forms has ebbed and flowed as customs and tastes have changed. In the middle of the 17th century, for example, the consumption of imported wine and local whiskey and ale was such that there was a large demand for bottles and drinking glasses. But this was only part of the picture. In the 1680s, as well as these bottles and glasses, the glassworks in Edinburgh were producing fine laboratory and chemist's glass, mainly to satisfy local demand from the university. In the mid-1700s, with rebellions fermenting all over the country, new glassworks at Leith and in Edinburgh were producing Jacobite glasses bearing a thistle motif. Early examples featured an engraved portrait of the young pretender. Then, after 1746, the portrait was replaced with symbolic designs. A rose with 1 or 2 buds, for example, representing the crown of England and the 1 or 2 pretenders who had a right to it. And the bubble in the glass's stem? It's the teardrop of Bonnie Prince Charlie. The tradition's a proud one, and it still hasn't died. As the 18th century drew to its end, people were drinking much less ale and developing a taste for wines, especially claret. The demand for more elegant and fashionable drinking glasses grew, and there was a 5-fold increase in production by Edinburgh glassmakers in the years up to 1800. The growth in quantity was matched by the excellence of the items that came out of Scotland, an excellence remarked on in Europe, as the director of the Edinburgh Museum of Science and Art noted.
In the Paris exhibition of 1867, the French reporters of the jury wrote in terms of great praise of the engraving and exquisite clearness of the material in the specimens of ornamental flint glass from Edinburgh.
At this time, the Edinburgh and Leith Flint Glass Company was well placed to gather the raw ingredients for their product. Where today's makers use sand, their predecessors used crushed flint and pebbles. The wealth of resources along its shoreline, the flints and the plentiful kelp which was burnt to produce potash, ensured Leith's position as a major centre for the industry. The company prospered, and in the 19th century moved to a new and much larger site at Norton Park, just off Leith Walk and Easter Road. And for almost 100 years, that was where they stayed. They knew the quality of their product, and they were proud of it.
Our crystal is quite unsurpassable in its brilliance, lustre, and uniformity. Those interested have only to inspect our wares to verify the truth of our claims. The dazzling quality of the glass, whether decorative or useful, rivals that made in the halcyon days of the trade. Its limpid nature is charmingly displayed in cut goblets, vases, and flower bowls of most chaste designs. A bewildering display, glittering and sparkling in 1,000 lights.
The company's history continued unbroken even during the austerity of the war years. Production was shifted from luxury domestic products to materials essential to the war effort. When the war ended, it left a legacy of difficulties of a different sort. Customers were tired of austerity and wanted the sort of goods they'd been deprived of for so long, and so there were lots of orders. But many skilled craftsmen had been lost, and the next generation appeared with a different outlook, different perspectives. In 1955, the company's name changed. It was now the Edinburgh Crystal Glass Company, and it soon needed more space. In 1969, it began the move to a 7.5-acre site at Pennycook, the Hill of the Cuckoo. The move took 5 years. First of all, the cold end was established. The hot end and head office functions finally followed in 1974. And Edinburgh Crystal was at home in what were then the most modern crystal works in the UK. Each year, over 100,000 visitors come to see for themselves the processes that transform very ordinary-looking ingredients into the beauty that is lead crystal.
Well, I think it's very beautiful. I was very impressed by the workmen and the atmosphere in the place.
It's amazing, really, the different stages and processes it has to go through before you get the final article.
I think the designs are wonderful.
The visit begins with a look at the materials that will be brought together, mixed and subjected to the intense heat needed to produce the molten glass. Perhaps surprisingly, a quarter of this mixture consists simply of broken glass, known as cullet. It's waste from the factory processes or from items which haven't met the quality standards and have been broken up. Recycling it in this way not only means that resources are used efficiently and waste is reduced, it also has a practical effect. It actually helps in the melting of the whole mixture. Weighing and mixing the ingredients is a critical business. The main oxides used are silica, lead and potassium. To the layperson, that's sand, lead and potash. It's a formula that's hardly changed for 300 years. The sand used is a pure, white, fine variety. It doesn't come from the beach. Beach sand contains iron oxide, which tends to discolour glass. For many years, this silver sand was quarried at Lochaline on the northwest coast of Scotland. The brilliance of crystal comes from the lead oxide, which increases its refractive index. This also softens the glass so that facets can be cut more easily to show the play of light on its surfaces. And the potash, which used to come from burning the kelp along the seashore, improves still further the crystal's clarity and increases its durability. All these ingredients, when mixed together, make up what's called the batch. Towards the end of the day, the mixture's loaded into the pots in the furnaces, where it'll melt down overnight, ready for the next day's production. The melting requires a temperature of 1400 degrees Celsius. Holding molten liquids at that sort of heat calls for vessels with their own special characteristics. They've not only got to withstand the heat itself, but they must be so resistant that they don't contaminate the glass in any way. Any cracking or crumbling would be disastrous. Each pot holds 800 kilos and is made of a specially formulated clay known. When the pots are full, these rings float on the surface of the molten glass. There's a tendency for a slight film to form as the melt continues, and these rings keep a central area clear of it so that the glassmakers can take a clean gather. Obviously, the lifespan of a pot is limited, as its inside is progressively eroded by the intense heat of its contents. Each one has to be replaced at intervals of between 6 and 8 weeks. The replacement process is known as pot setting. About 5 days before it's brought into use, the pot's placed in a special furnace called a pot arch and gradually heated up to 1430 degrees Celsius. First of all, the old pot has to be removed. This means taking off the front of the furnace. It's hard work, and it has to be done in a radiant heat of some 1200 degrees. When the two large panels are eventually prized free, the wave of heat that flows out is indescribable. The old pot can now be removed and is taken outside to cool. Once the base of the furnace has been cleaned, the new pot can be set. Obviously, there must be no chance of it cooling during transfer, or it may crack. So the forklift driver has to take it out of the pot arch and move it quickly to the furnace. One mistake from him, and the whole 5-day process would have to be repeated. It means combining speed and great accuracy. There's very little leeway at any stage of the transfer. With the pot set, a new front has to be built onto the furnace. Once again, this means working close up against the full blast of heat. Resetting the panels, building up the bricks, and eventually cementing them in place with more of the special clay. When every gap is filled, the furnace is ready to receive its first batch. As we said, the melting temperature for a batch is about 1400 degrees Celsius. The melt continues through the night. By morning, the pot contains molten glass, ready to be gathered. The working temperature when the glassmakers start taking their gathers is between 1080 and 1150 degrees. The smaller items they're making, the more fluid they need the glass to be. So that means a higher temperature. Teamwork and flexibility of working practices are essential. The number of people in a team can vary from only 3 members to up to 9, depending on the item being made. Techniques are very similar, but different skills are needed for different pieces. Here, the team are making a medium-size thistle punch bowl. The first member of the team's the blower. He takes a gather, blocks it into shape, and begins to blow into it to start the bubble forming. He adds another gather to the first and keeps working the glass until he estimates the size is right. Then, still turning his iron, he lowers the bowl into a mould and blows into the glass to form the familiar thistle shape. In the old days, another team member was needed to open and close the mould by hand. But today, everything's controlled by the glass blower himself. The second team, so this mould is now known as the mechanical boy. It's important to keep the bowl at its working temperature of between 600 and 800 degrees Celsius while the leg and foot are being added. Otherwise the glass will crack and the whole piece will be ruined. The next member of the team is the servitor. He's given a gather of glass which he begins to block and smooth into shape. When it's ready, he takes it to where the bowl is waiting, drops it onto the bowl's base, and begins to form the leg. With larger pieces like these, the glassmakers have to keep taking the glass back to furnaces known as glory holes to keep it at the correct temperature to work the material. Eventually, another gather is taken to be formed into the foot of the punch bowl. At various stages, more molten glass is added to the top of the bowl, at the point where it's being held on the iron. This isn't part of the design. It's simply to maintain the glass's temperature and prevent it cracking and falling off the iron. At last, when the servitor's satisfied that everything is as it should be, he cracks the finished bowl off the iron. And it's taken away to be put into a kiln where it'll cool gradually overnight. The techniques are basically the same for smaller objects, like wine glasses, The blower takes a gather. He smooths it in a wooden block, and once again blows it into shape inside the mould. The bit gatherer gathers a blob of glass which he gives to the servitor. It's shaped into a stem. And eventually another bit is gathered, which becomes the foot. The tools, pallets, formers and moulds the glassmakers use are all made here. The wood used is pear, which is hard and has a smooth surface. Moulds and pre-shaping blocks are lined with cork. This gives good heat resistance and also absorbs moisture. The block is dipped in water, and the steam which is created between the cork and the blown glass gives a smooth finish. Once a shape is established, carbon and steel moulds can be made, which last longer and give a more consistent finish to the surface. Watching teams at work with the flowing glass is a constant source of fascination. Even the trickiest manipulations are made to look simple by the glassmaker's skills. Lips and handles are created for jugs. Perfectly aligned and with exactly the required dimensions. And in an astonishingly short time, a blob of scalding liquid becomes an elegant swan. The final working temperature of the glass is about 500 degrees Celsius. It has to be brought down from that to room temperature very gradually. The cooling happens either inside a kiln, like the one we've already seen, or in ovens, like this one. It's called a layer, and the pieces produced by the team pass slowly through here for a period of 2.5 to 5 hours. At the end of the layer, each item has its first inspection to show up any blemishes. If it passes at this stage, it moves on to the next process. If it doesn't, it's smashed in the cullet bin to be recycled in a future batch. When the glass is first blown, it fills the mould and is forced out of the top. This leaves a portion called the overblow, which has to be trimmed off. That's what happens here. The glass is first measured for height, then scored around with an industrial diamond. The glass is then heated and cooled at this mark. The expansion and contraction causes the glass to crack, and the overblow is thrown away, another candidate for the cullet trolley. The overblow on larger items can also be removed by this machine. In this case, the main part has already been removed and the bowl is being trimmed to the correct height. The saws are made of stainless steel with a diamond edge and they rotate at 3000 RPM. For smaller items, the same techniques apply. Glasses are scored, then heated until they crack, and the overblow drops away. This obviously leaves a sharp edge, so it has to be ground down. This second machine is set to cut two bevels, one inside and one outside the edge. There are two carborundum pads, one rough and one finer, which smooth the edge before the final touch. For glasses and other smaller items, there's one more finishing touch. They're passed through a gas jet, which melts the rim to create a smooth, rounded edge. Cutting patterns into lead crystal multiplies the number of prismatic reflections and increases its brilliance. The markings being applied here are simply guidelines for the cutters. They're only providing the basic grid to fix the design structures accurately on the glass. There are some pieces which the machine can't cope with, and they're done by hand. This used to be the way every piece was marked. The pens, and perhaps the patient's skills, are from another age. This is the next stop, the cutting room. A lot of work has already gone into the production of each item. Just one false move on one of these wheels, a slip or an over-enthusiastic pressure, and the piece becomes coloured. A cutter needs a steady hand, a good eye, lots of concentration, and at least 4 years training. When you watch cutters at work, their skills are clear. Their familiarity with not only the material, but also the patterns they're cutting into it, means that they very rarely have to consult a design. They use various types of cut, with exotic names like diamonds, swags and flutes, which are built up in layers to create ever more complex patterns. But even a minimal amount of cutting is enough to reveal the crystal's inherent beauty. Wheels used to be made of coarse carborundum and fine stone. The first gave a rough cut, the second smoothed it. Nowadays they have a diamond-impregnated edge and rotated between 200 and 4,000 RPM. And the work doesn't just consist of tracing delicate little patterns. Try picking up a bowl like this and imagining what it's like to hold it and turn it against a wheel for a few hours. As the wheels cut into the glass, they leave lots of tiny scorings over the cut surfaces. The next process is designed to remove them to create the familiar crystal finish. That's done in the polishing department. These decanters are about to be dipped in acid, but it's only their outside surfaces that need polishing. So, to make sure that no acid can get inside them, they're going to be capped. First of all, they're part filled with water. Then a top is put on and a vacuum is created inside. The decanter's turned upside down to check for air bubbles. As long as there are none, it's ready to be dipped. The first dip is in detergent. This gets rid of any of the ink markings that may still be on the surface. Each basket load of glassware is then moved to a bath of hydrofluoric and sulfuric acids. This removes a very fine layer from the whole surface. During this first immersion, salts form on the surface of the crystal. To get rid of these, the glasses are dipped in another bath, this time of sulfuric acid. The cycle is repeated until the crystal achieves the optimum polish quality. At that point, it's washed in water, then rinsed, dried, and hand polished. Each item is also inspected again. The gauge here shows that a vacuum is being created inside the glass and that there aren't any holes in it. Even the tiniest hole will prevent the needle moving and the glass will be rejected. As well as cutting, there are other types of process used to create effects on the surface of the crystal. These are stencils. They mask the glass, leaving only the logo, pattern, or text exposed. Each piece is then held in a jet of fine sand which is etched into the glass under pressure, thus frosting the surface. Different maskings and the variations in pressure produce very different effects. Engraving adds yet more variety to the distinctive styles of Edinburgh crystal. It etches even greater detail into the designs to make each single item a unique, handcrafted piece of glassware. Here we see the phases through which our thistle punch bowl passes. From its initial stage to the removal of the overblow. It's then marked and cut. Polishing removes the frosted surfaces, and engraving adds the finer details. Engraving is a fascinating reversal of the normal way in which pictorial artists work. Usually a brush or its equivalent is applied to a surface. Here, it's the surface that's moved over the engraver's wheel. The wheels are made of copper, which is lubricated by a mixture of oil and emery powder. They can be anything from 4 inches across to the size of a pinhead. And the effects the engravers achieve with them are astonishingly varied. The popularity of Edinburgh crystal has grown over the years. And to keep up with the demand for the brand leader's product, Edinburgh crystal not only continues to invest and develop in its manufacturing plant, but also has agreements with select European crystal specialists to produce crystal items to strict specifications, all of which are designed in Scotland. While the country of origin label on every piece of crystal will tell you whether the product was made in Scotland or elsewhere, every first quality item bears the purple logo of Edinburgh crystal. Additionally, all first quality items carry the prestigious Edinburgh crystal back stamp. Thanks to the processes that we've seen, items that began life as handfuls of sand, lead, and potash are sent from here all over the world. Just as the European exhibitions appreciated the brilliance and luster of those 19th century products, so collectors of crystal from America to Japan, from Canada to Australia, and from Banff to Brighton are still drawn by the special, timeless characteristics of the finest crystal from Scotland. The fascination of everything that's involved in glassmaking brings more and more people each year to Pennycook to see for themselves how it all comes together. But better than that, Nowadays, they're given the chance to actually practice the skills that make up the mystique of the glassmaker's art. These are the hands-on VIP tours that are becoming so popular.
They let you get close on and have a little go at everything. They didn't make you stand back.
Well, you often look at a glass and you wonder, how do they do that? And then when you come on a tour like this, then you see how they do it, and it's very interesting.
Thoroughly enjoyed the tour.
Glassmaking is an ancient art, but it's also a dynamic part of modern life. Fashions and everything have come and gone, but there are some things that manage to retain their age-old fascination and use it to connect us to values and priorities that otherwise seem to have been lost. The ghosts and echoes of old Scotland are never far away. Its traditions help to define it. And it's that identity, spanning many centuries but vigorously part of today, that's right at the centre of the story of Edinburgh Crystal.
Aye, come on.
It's quite handy when you can see what you're doing, isn't it?
Aye.
I take it this is for yourself, is it? tell everybody that's a crucial part of the process, writing your tag on it.
I've just got to say, I've got to show this part to any king. Watch it. Just a bit of feeling.
Am I?
Let's see if we can find Mummy then, shall we? She's got to be around here somewhere.
Hello. What are you doing here?
Oh, well, what? We thought we'd come along and surprise you, didn't we? So, aren't you pleased to see us?
Of course I am. What a lovely surprise.
Yeah. Where's Keita?
She had a terrible toothache, so I thought I'd come on my own anyway.
Yeah, why not?
Yeah, it was a wisdom tooth.
Oh, right. Oh. So how comes you aren't in the building?
Oh, I got waylaid. Oh, she was in a right state and she'd run out of aspirin, so...